So now I want to go on to some ideas that I want to get you to think about. And this is sort of, you might say, this is us sitting in universities trying to understand and explain to our students what the nature of these supply chain disruptions are, so our students can sort of think about it and think about strategies, and more importantly, explore best practice. So with that, let's go to the next slide. So the agenda is to really think about issues and ideas regarding managing supply chain disruptions. And Ed, you can click away a bit. So the first thing is for us to understand reasons for these disruptions, and something that I think you might say, well, why do I need to know this? Really to explain or help us understand how we, wherever we sit, are connected to the world. So some examples, of course, one of the things that everybody these days is an expert on is really the Suez Canal, all the ports and backups, all of those things, which are interesting. If you click further, we've all heard about chips in the auto industry. If you click again, grocery supply chains, many of us who go to the grocery store and look at things being in short supply. And finally, a lot of stories about FedEx, Tesla, Toyota, Walmart. So I'm hoping to give you all of this and just to explore some ideas that have been reported on to manage supply chain disruption. So let's sort of think about the supply chain and bottlenecks. And Ed, you can just click. So upstream is the upstream supply side, downstream is demand. And if you click forward, the main thing we're focused on is this intermediate entity. So again, if we click ahead, you can think of this intermediate entity, and Ed, you can just keep clicking along. There's a demand downstream, there's a supply upstream, and this really is the supply chain. And when we talk about disruption, we're either talking about an increase in demand for the same amount of supply, a decrease in supply for the same amount of demand, or a problem in the processing entity. And of course, you might say, what about all of the above? So let's look at the Suez Canal. And if I just show you this picture of this ship in the Suez Canal, you realize that once this ship is blocking this canal, very little else can move along. So let's just talk about the Suez Canal blockage. So the Suez Canal is 120 miles long, and some regions are 300 feet wide. This particular ship had 20,000 containers. Just to give a quick idea, there are about 19,000 ships that cross the Suez Canal in 2020, 39 ships daily with a maximum of 106. And of course, you realize the volume of global trade that goes through the Suez Canal. The key here, when we talk about the Suez Canal blockage, is that the bottleneck lasted 6 days. And during this 6 days, there was no traffic that went through the canal. And at the end of those 6 days, there were 360 ships waiting to cross. Now, for many of our students, we basically say, well, where did the number 360 come from? Obviously, if you take the number 40, it's about 40 ships per day, multiplied by 6, that's about 240 ships. Those were 240 ships that could not cross that week, so they were all waiting. And in addition, there were new ships that came in, and all of that resulted in this 360 ships. So if you take these 360 ships and you operate at the maximum capacity, it would take 3 days to clear the backlog at the canal. So you might say, why is this a big problem? You were delayed for 6 days, another 3 days. But remember, a large number of the companies that were relying on the containers on these ships, and a large number of the ships that were very large, you can imagine the impact it has throughout the system. So if we go to the next slide. Now I want to get you to think about all those containers going through and ask, well, how much is actually being imported into the United States, and how has that changed over time? So the x-axis is months, the months January through December, 1 through 12. The y-axis is the 20-foot equivalent units, which is, you can think of as sort of a standardized measure of a container. So 40 foot would be 2 TEUs. And if you look at the numbers are pretty small, but in effect, if you take those numbers are in the millions, right? So I've written down the full number. So if you look at the data, if you start with 2019, you see a set of numbers in 2019 that are generating about 2.5 million on average per month. That's 2019. let's look at what happened in 2020. Ed, can you just hang on a little bit? So if you look at 2020, you realize that as expected in the early part of 2020, because of the pandemic and a lot of shutdowns, a lot of the volumes decreased. So the first half of 2020, you see volumes which were lower than 2019. But notice that by the time you hit December of 2020, you see a recovery. So all of those orders that had not been placed now come sort of surging back. The part I want you to look at is 2021. Look at the numbers for 2021 every month. And you start seeing that if you look at the total number of TEUs in millions imported in the United States, we went from 30 million to about 29 million to 35 million. And so if you take all your ports and if you look at all of these orders, should we be surprised that there were bottlenecks? And clearly the answer is no. Should we expect that there'd be such a surge back? Well, there was a slight drop in 2020. Perhaps nobody expected this big surge. But then if you say, where would the surge come from? Well, if you're a procurement manager, you would just start planning just in case. You would start worrying about what if there's a pandemic? What if there's disruption? So you would build up safety stocks. Well, the problem is everybody decided to build up safety stocks and all of this volume grew. So this is really gives us a picture of the stress to the system. So you might say, where did you get this data from? It turns out that the United States is one of the countries that permits all of the import of every container, that data to be purchased. So we at Purdue purchased this data, and we purchased this data and got 130 million fields of data, which gives us for every container, it gives us all the details regarding the company that shipped it, where they were located and their address, the ship that carried it, the port it landed on, who the consignee is, what the consignee's address is, and the details in the bill of lading and what's there in each container. So we now have a very large set of data that we host on the Amazon cloud, and we build a Power BI interface to query. I'm telling you this just to say that in the modern supply chain world, that's what it takes to understand what's happening globally. And I'll give you some ideas, but here's an example where we would love to partner with any one of you on the call to have our students work on this and try to get greater insights into opportunities or alternatives. Opportunities in the sense you can understand products you make, who is purchasing them, from where, which company, where they're located in the United States. But by the same token, you could say, here's where I'm purchasing my product. Where is everybody else buying the same product purchasing from? Who are the suppliers? And all of this data is available and can be mined. So this is just to give you an initial look at the volume increase that caused the stress in 2021. Next slide, please. So here's some more data. The first is Los Angeles. So Los Angeles and Long Beach are the two ports that pick up approximately 30% of the total volume. In November 2020, there were 6 ships waiting to unload. In November 2021, that number was 70. Okay. The wait days to unload was 18 days in November 2021, and it was 1 day the previous year. The containers on the dock waiting to be dispatched, that is waiting to be picked up by trailers and moved to other country, went from 5% to 30%. So there's a greater delay. And notice that this combination means that the dock is going to run out of space because all these containers are taking longer to get moved out. Then the empty containers exported went from 60 to 80%. This means that exports get delayed because they don't have containers to go out on. And one of the things that everybody was talking about was the increase in shipping rates. So China to Los Angeles, the rates went from $2,000 to $10,000 per containers. Many of you can remember numbers that people were citing that went up to $25,000. So this was an increase in prices. And of course, just based on the picture I showed you earlier and some of these delays, This is normal. If you have a fixed amount of capacity and there's a huge amount of demand, the only way the market clears is that prices clear the market. So people who really don't need it can sort of decide to wait. One of the interesting things is that transit time increased, and this transit time included time waiting to unload, because it wasn't just the fact that ships were traveling slower, it's just that after ships were traveling at the two ends for loading and unloading, things took longer. So that was an increase. And of course, as I mentioned before, the volume increase. So if you look at all the pieces of data on the screen here, this is the perfect storm. Longer times, delays in moving containers, higher rates. And if you're a procurement manager, this is your supply chain disruption. Next slide, please. So here, there are many, many things that contribute to it. So if you look in more detail, one of the things you notice that if you look at volumes, we've been talking a little bit about China, but one of the things to note is that if you look at volumes of containers, the country from whom container volumes has been increasing rapidly is Vietnam. So as China decreases some of its production, and if you might say, why is China decreases its production? One of the things that we haven't talked about is that China's population is aging rapidly, and some forecasts suggest that by the year 2100, China's population will be 550 million. It's currently close to 1.4 billion. Now, why is that? Because of the one-child policy, there's a far fewer people entering the workforce. And all of those people do not want to work in manufacturing. They want to work in jobs with higher margins. So where is this production going? To units set up in Vietnam, units set up to many other countries in Asia. What happened in Vietnam? As you'll know, Vietnam in the early part of the pandemic had 0 cases reported, 0. All of a sudden, it increased dramatically. They had a complete shutdown of all of their manufacturing, and that created problems. There's problems in unloading. You may have heard of shortage of chassis in Long Beach and Los Angeles ports, and also shortage of trucks to unload at US ports and delays. At this point, you might say, enough already. I don't want to wake up this morning and hear a litany of woes. So what is everybody doing? So let's look at the next slide. So I want to get you to think about a few examples. So here's an example from FedEx Logistics. So what did they do? So FedEx Logistics was importing a large number of empty containers. Now, I know we have our friends from Wabash here, so I'm sure there's probably a reason why FedEx is importing containers rather than buying them here from Lafayette. But FedEx was importing empty containers from China, and they were importing them from the port of Hunan in China, from the port of, I hope I'm pronouncing this right, Hunan in 100 miles from Los Angeles. What did they do? Well, Port Hunan is a US Navy terminal, if you move forward. And what they did is they were shipping about 300 units of the 53-foot containers per sailing. This port was fairly empty. In 48 hours, you could turn around. So what did they just do? Their solution was to offer up all these empty containers as capacity to move things. What's the issue? The ships would be smaller, so there'd be a greater transport cost per unit. The containers would arrive at the wrong place, this is not the standard place, but you could turn around fairly quickly. So an alternate port, higher rate per trip, but lower total logistics costs. Now, of course, FedEx is a logistics company, so they started offering this capacity. So this was one solution. And the idea in this solution is to basically trade off the higher rate, smaller ship, but lower logistics costs because of faster turnaround. You recall that I told you about all the delays disappeared. So this is one possible solution, something that FedEx did. Next slide, please. So what did Walmart do? And here you can click through. Earlier, Walmart's cargo was split across many ships. And in fact, in our data set, we can actually look at the particular ship code, the vessel code, to see which vessels had Walmart cargo in it, where did they arrive, etc. Well, when you share a ship with many other people, you can't demand rerouting if you're 5% of it. So what Walmart decided to do is charter its own vehicles to carry cargo, These were smaller sized vehicles. Many of you who are keeping track of ship sizes, I gave you the example with the Ever Given, just 20,000. Ships are getting bigger and bigger and bigger so that a cost per unit is going down. But the problem with these bigger ships is that they can only go to certain ports that can accommodate them. Whereas the smaller sized vehicles, the 4,000 to 6,000 TEU vessels, can go to many other locations. So if rather than going in a very large ship, you chartered a smaller ship, you have a lot more flexibility. So Walmart started using ports such as Seattle instead of LA or Long Beach. This means that they would go to a port which would be different. They may need to pay slightly longer transportation, but much less weight. And this allowed them to get the product. This basically says greater travel and trucking costs, but lower overall logistics costs. And Walmart actually claimed to have 11% higher inventory at the start of December 2021. So what this tells me is that, yes, while everybody was stuck with these bottlenecks, the places that had logistics managers who were flexible, who were thinking about overall cost of operation rather than the cost of each individual step, they somehow managed to improve and run the system. Next slide, please. So I wanted to talk a little bit about chips for automobiles, and Ed, you can click through the various things here. Usually chip inventory is about 40 days. And in many companies, it had decreased down to 5 days. Ford, General Motors had to curtail production, but I do want to get you to think about one little detail. Even though they curtailed production, their profits increased, okay? Which means, now you might say, how did that happen? They sold less units. They sold less units, but they had to discount a lot less. So cars on the lot were selling closer to list price. And so, of course, you realize that revenue is price per unit times quantity. If quantity decreases and the price per unit increases, your overall revenues may remain the same, and you may, in fact, increase profits. Well, unlike Ford and GM, Toyota had carried 6 months of chip inventory. And you might say, well, isn't this the company that did just in time? Well, yes, they did just in time, but they realized that the chip supply chain had potential for disruption, and it may be best for them to carry inventory. So at least in 2020, they had minimal impact. If you look a little more in detail, you realize that chip manufacturers claimed that the reason for lack of chip availability is that the chips used by the auto manufacturers were an older generation of chips, not the current generation. And you might say, well, why is that? A lot of the chips were being used in components, and those designs were being done by suppliers who were being squeezed for price by the auto manufacturers. And so they decided to use chips that allowed them an affordable price bit. In the new system, Ford, BMW, et cetera, have decided to work directly with chip manufacturers. And of course, chip manufacturers love it, where they can work directly with OEMs. Those of you who recall that there's now an Intel plant announced in Ohio, you say, why is Intel in Ohio? Well, so that they can work directly with the manufacturers and ship to manufacturers. So, but while all of this is going on, you might say, well, while the rest of you were affected, how did Tesla ship 82% more cars in 2021? Interesting question. So a few comments regarding Tesla. Tesla is more vertically integrated than other auto manufacturers. They control the entire design, and they have a more flexible hardware-software boundary. They can reshuffle how tasks are being done. They were using current generation chips, obviously were based in Silicon Valley, and they managed to reconfigure their chips to maximize output, and in some cases, postpone some functionality to later. They also used greater automation for production, so they were less affected by labor disruption, and they shipped 82% more product. In fact, Tesla uses the Fremont plant. Those of you who recall Fremont, this was the plant that was NUMMI, where Toyota and General Motors were producing. And Bloomberg just announced them as the most productive auto plant in the world ahead of Toyota. What this says is that there's a lot of disruption coming in how we're going to make things. And even the bread and butter automobile is going through a tremendous amount of shifting. As I say this, I recall everything that Bob Galen just said, that there's a lot of change happening at the battery world too. So all of us sitting here at Purdue are actually deeply thinking about how our curriculum should change, what new degrees we should come up with just to get our students ready. Next slide. Grocery, here you can just click through quickly so I can catch up. So the grocery industry historically has carried a lot of finished goods inventory, 80 to 120 days. The pandemic caused a shift in volumes from commercial to retail, which means that even if you think about toilet paper, paper towels, etc., 50% of the time people were sitting in the office during the day when they were awake. That shifted to the home. So everything that was purchased in commercial volumes shifted to the home. Same is true with industrial kitchens, etc. A lot of companies shifted to the 80-20 rule. Let's make the basics, decrease the variety. This happened for toilet paper, paper towels, disinfectant, pasta, etc. But the virus also created variability in retail staff, warehousing staff, drivers, etc. And this is really where we saw the public starting to get worried about what was going on. Next slide, please. A few ideas. And Ed, you can just click through all of the things here. When we talk about ways to manage disruption, we say, well, how is capacity, inventory, and lead time used? For all of us here at the Dow Center and at the Global Supply Chain Management, and you've heard from Steve Dunlop, you'll hear from Angus in a few minutes, and you'll also hear from Roy. We've been looking at what's called a smart TP3, which is deploying technology to impact people, product, and process. And some of the ideas we've been thinking about is how cross-training of people can help with flexible deployment. If somebody doesn't show up, somebody else helps out. Value stream mapping, keeping track of potential for infection, and therefore minimizing exposure. And technology, remote forklifts, which we just announced recently, AR glasses, sensors, cobots, etc., all towards improving productivity and helping people operate. And some of the other ideas we're thinking about is can we create some ad hoc supply chains, and how can we make people aware of the entire supply chain so you can identify where the bottleneck is and fix it. Next slide, please. So you can click through all of this quickly too. So there were a few ideas that are now being thought about, and we'll ask you about them. There's reshoring, which is something that you've heard about quite a bit, that is bringing production to the United States. The other is nearshoring, where you're thinking about potentially bringing production back to perhaps Mexico or Latin America so that the travel is much less and you're less exposed to delays with respect to ships, etc. And finally, a regionalized strategy where you take advantage of local production with back and forth so that the distance traveled is lower, you have a greater handle on handling disruptions. Next slide, please. So with this, I want to stop, and I hope that I've given you a few ideas to think about.